Okay, let's go to the example for the bearing. Okay, so you are given to want to calculate the C10 load for a ball bearing used in the operation condition. Okay, you want to find out C10 and the load, radical load given is 5 kilonewton, bearing using for 8,000 hours, 1450 RPM. This one all happen with 90% or 0.9 reliability. So that means this is the value FD desire, LD desire, and happen in 1450 RPM. This one is the input. So this side is C10 L10. This is FD LD. This is ball bearing, so it's 1/3. So is the L10 is fixed 10 power of 6 revolution. L10. LD is 8,000 hours. 60 is just a number and RPM. So you get this one. So substitute inside the formula and the F is put at here. The force is put at here. Okay. So divide by L10. So you get value of C10. Is the Newton, is the load. So this side calculation is same with this one, C10, and calculation at here. Okay, it's the same, same answer with different method. Okay, this is one of the example. So we go another one. Want to find C10 for ball bearing. Okay, so happen at the bearing 2 kilonewton. This one is the FD desire. Okay, is your external load. Bearing expected used for 5,000 hours. This one LD and RPM. 1 to 5 C10. Okay, 1 to 5 C10. Okay, so it's the same method. L10 always is a fixed value and calculation for LD. Okay, 5,000 hours, 60 and RPM. Substitution inside, you'll get the answer. C10 answer. So one side is the fixed one from the catalog. This one is from the desirable. So we get this one, C10. Another one, calculate the operation FD for the roller bearing rate at the 26 kilonewton used for, now to find FD, right? So you use at the 300 RPM, 8,000 hours. Okay, so C10 is given, LD is given, N is given. So substitution inside, LD also fixed, L10 is fixed, LD is calculated out. Okay, now the C10 is given. So rearrange it, we get the F desirable. This is the force. Okay, either you use this formula or using this one, is the same. Okay. Okay. So single deep groove ball bearing, 3 kilonewton, shaft rotation 600 RPM. Life is 30,000 hours. What is the minimum diameter of the shaft? The minimum diameter of the shaft is given 40 mm. Okay, what is the suitable selection? Okay, so FD is given, N is this one, L10 is given, and D. Okay, so substitution inside the formula. So we get the value of C10. Okay, this value of C10, we will want to check from the catalog. Later, I will show you a complete catalog. Okay, this one is from the one page of the catalog for the bearing. This is the D, small diameter D, and so on. And the C10 value, we will refer to this one, basic load dynamic here. You will find that just now the C10 value is 30,000. So we need to find out the value of basic load must be more than this value, C10 value. So it's 32. Okay, with the input D, okay, with the spec of the bearing, so we only can choose in this range only. More than that, sure can, but there will be more higher cost. So just a little bit more than this is good enough. Okay, so 32. So this one is kilonewton. So the spec you choose is 6280. This is the bearing code SKF you can choose. Okay, can so that's why we want to find out the C10 value, because from the desirable input, everything we get the value C10. So we want to refer to catalog value to find out which one the model is the suitable to using up for your design. Okay. Okay, so this one is the catalog. SKF, this one I will upload to you also, rolling bearing. You see, the input there will be quite a lot of information. This one is very complete. They were using in the industry. So roller bearing, okay, a lot of different types bearing, a lot of difference. Okay, 1000 page. Okay, let's say I just randomly pick some page. Okay, so they will give you the, so this one is a single row deep groove ball bearing. So the D, where is it? Big D, small d, all information like that. So we want to find out this one, dynamic, basic load dynamic C. Okay, so with certain value, with certain small d, your requirement, so we will refer to what is the bearing code you need to find out. Okay, it's the bearing code. So this one is the range lah. We go to find out the suitable one. So this one is, there will be a lot of full of the information. Okay, they will give in all the different types of the bearing can be applied in here. Okay, just roughly go through. Okay, how to install, how to mounting, and so on. So this one is the industry using for that. Okay, so I will send this one to you as a reference. Okay, so for bearing, nobody go to manufacturing up. Okay, they already have the existing one. You just need to choose the right one for the bearing. Okay.